Now we're at the place where we can talk about the limit that we're concerned about. This is the limit as theta approaches 0 of sine of theta divided by theta. The argument for the value of this limit is geometric, and let's take a look at how this would go. Okay, all right, if we have a circle, and let's call this the unit circle, so its radius would be 1, all right, inscribed in that circle, let's have a triangle, and let's suppose that its central angle is theta. Okay, all right, we can come up with the area of that circle. We will in area of that triangle in just a few minutes. But notice this point here, since it's on the unit circle, this point has for its x-coordinate cosine of theta and its y-coordinate sine of theta. Next, let's look at the sector. I'll take this sector. All right, we've seen already that in a right triangle, the area of the sector is 1/2 theta. Okay, and then finally, I'll look at this big triangle that's outside, and we'll see the area of that. This leg is 1. We'll find out that this leg here is tangent of theta, and we'll see, so then the area is 1/2 tangent of theta. We'll see that in just a few minutes. All right, now the idea is that the area of the little triangle, or I should say, is less than or equal to the area of the sector, and which in turn is less than or equal to the area of the big blue triangle. And we'll look at that. Because of that, we'll see that relationship, that order relationship, little triangle, sector, big triangle, stays the same as theta goes to 0. This will help us with our limit. Okay, so let's go back and let's take a look at this. Again, suppose that this angle here is theta. This point here on the circle will have its x-coordinate cosine of theta, and as its y-coordinate sine of theta. So if I would drop a perpendicular from this down to the x-axis, all right, this much would be the x-coordinate, that would be cosine of theta, and this much would be the y-coordinate, that would be sine of theta. And so the area of this is going to be 1/2 base times height. 1/2 cosine of theta is the base times the height is sine of theta. All right, this area is less than or equal to the area of the sector. And again, if the sector had angle theta as its central angle, from before we saw that since this was the unit circle, the radius was 1, the area of that sector was 1/2 theta. And finally, if this is angle theta, all right, then, excuse me, and this is 1, let's call this side, I'll call it H for the time being. All right, and notice that tangent of theta is the opposite over the adjacent, so that would be H over 1, or simply H. So this H must be the same thing as tangent theta. And remember that the area of the sector was less than or equal to the area of this blue triangle, and the area of this blue triangle is 1/2 base times height. That would be 1/2 times 1 times the tangent of theta. So we have this relationship, okay? 1/2 cosine of theta times sine of theta is less than or equal to 1/2 of theta, which in turn is less than or equal to 1/2 of tangent theta. Okay, what I'm going to do is I'm going to divide both sides by sine of theta. We're assuming sine of theta is positive, And so if I do that, I'll have 1, well, maybe let me first of all multiply through by 2, so that I'll have cosine of theta times sine of theta is less than or equal to theta is less than or equal to tangent of theta. Okay. Now let me divide through by sine of theta. If I do that, all right, I'll multiply each part by 1 over sine of theta. I'll be left here on the left end of this inequality with just cosine of theta is less than or equal to theta divided by sine of theta is less than or equal to, well, over here, remember, tangent is sine over cosine, so if I divide by sine, I'll simply be left with 1 over cosine of theta. I'll be left with 1 over cosine of theta. All right, now we're going to do something that you may not remember ever doing before. All right, but what we're going to do is we're going to reciprocate these. All right, we're assuming that all of these are positive, that this is a positive number, this is a bigger positive number, this is the biggest positive number. All right, and the thing is, if we reciprocate two numbers, all right, what happens is we change the order of an inequality. For example, 1/3 is less than 1/2, but if I reciprocate both of them, I get 3 and 2, and 3 is of course bigger than 2. I have to change the value. This works as long as these two numbers have the same sign, if they're both positive or both negative. All right, so I'm going to do this. I'm going to take the reciprocals, and I'll have 1 over cosine of theta is greater than or equal to sine of theta over cosine over theta, I'm sorry. And that in turn is greater than or equal to excuse me, cosine of theta. All right, now let's take the limit of all three parts as theta goes to 0. The limit as theta goes to 0 of 1 over cosine of theta is greater than or equal to the limit as theta goes to 0 of sine of theta over cosine over theta, I keep on running right, cosine of theta, is greater than or equal to the limit as theta goes to 0 of cosine of theta. Now, of course, as theta goes to 0, cosine of theta goes to 1. Cosine of 0 is 1. Cosine is continuous everywhere. So this is, we could say that this is 1 over cosine of 0, all right, is greater than or equal to this limit as theta approaches 0 of sine of theta over theta is greater than or equal to cosine of 0. And the sine of 0 and the cosine of 0 are 1. So 1 is greater than or equal to the limit as theta approaches 0 of sine of theta over theta is greater than or equal to 1. Well, then the only alternative for for this limit of sine of theta over theta is that it has to be 1. It's between 1 and 1. So the limit as theta goes to 0 of sine of theta over theta is equal to 1. Now, I should point out something, that when we use this formula, for the sector of the area of a sector, all right, we assume theta is in radians. Okay, so this limit only works for theta in radians. Okay, this limit only works for when theta is in radians.